Hello, I'm Eric Hanley, an automation specialist with ES&E, and in this video segment we will cover how to animate some basic graphic elements in FactoryTalk View Studio Machine Edition. We will also cover the 3 different methods for testing within FTView when you do not have a panel view. For our demonstration, we are going to be animating a selector switch and a tank level, along with creating a generic indication object, a numeric input to adjust the timer, and a multi-state indicator for the tank state. We will also be adding a simple screen navigation and ActiveX object to launch a PDF. But before we get into our demonstration, we will quickly review the methods for testing our application. The first method, which we are primarily going to use, is test display. To test one individual display, you will hit the play button on the header bar to allow you to see live values as long as you are connected to a controller. The test only functions for objects that are on that screen. It will not work with global objects, nor will it allow you to navigate off of the screen. The second method is called test application, which creates a temporary runtime. This will compile your application and run it as if a runtime is being opened by the application in the top left corner of your PC. Test application allows you to test navigation and verify that other functions are working, but it doesn't work for global objects or macros. The third and final method is to create a runtime and then run the FTView ME station on your PC. So FactoryTalk View Studio automatically installs ME station that allows you to replicate the panel view on your computer. The only thing that would be different is if you are launching something from memory or pulling anything from the panel view memory. The memory location will be different. Now that we have reviewed different testing methods, we are going to create a new application. Let's use the FTView Studio shortcut, then select Machine Edition Application, and then select New tab on the top. We will name the application FTView_ME_basics, and then we are going to choose a PanelView Plus 7 9-inch Standard Edition. On the New tab, there is also an Import button, which allows you to convert Panel Builder applications or import a project that was exported. If you have an application with the same name, then you will need to rename or delete that application using the software called Application Manager. Application Manager is where you can restore an application, restore a runtime, rename an application, or delete an application from your PC. Once the project hardware is selected and we gave it a name, then we click Create. Let's go directly to our Displays folder, which will always start with an alarm page, diagnostic banner, information banner, and then the main screen. We're going to start developing on the main screen. One element to note that is created by default is the shutdown button. You do not need to keep that button on the main page, but each PanelView Plus project requires a shutdown button. The button is needed in the event that you need to get back out to the ME configuration. In the event that you delete the button, you can always add another one using the icon that looks like a power button. It does not shut down the panel view, it just shuts down the application. On the main display, let's change the background to a darker gray so that it is more visually appealing. Then we will add our first object that is on our list, which is a selector switch. We're going to represent that using a maintained push button. Select the push button, then drag and make it the size that we want. You can change the next state based on value control or current state. Since we only have 2 states, auto and manual, we will use the current state. If you have more states, value control would be a better choice. The Common tab is where we can adjust the size and position of an object based on pixels. This button will be 100 by 100 and positioned 50 pixels from the top and 50 pixels from the left. Moving to the State tab, we want State 0 to be manual. You can then insert a caption to write on the object, but I want to represent a physical toggle switch, which can be done by adding an image. Hit the ellipses or the 3 dots, which will launch all the embedded images. But if you don't see what you want, you can select Launch Library. The library is actually your symbol factory, which is also shown in your project organizer. The symbol factory has numerous different objects, And if you still don't see what you want, then you can also create your own. Most of the time, you will find an object that will work for you, but if you want to make small changes, you can open the Options tab. The Option tab allows you to change orientation, rotation, color, and background. We don't have to create a custom rotation because there are multiple objects already built. Once you find the object that you want, you need to select Copy and then select Paste from Library. That launches a pop-up where you give the object a unique name. For our object, it will be Selector Switch Left, and then we will click OK. Now hit Apply to preview what the button will look like with the new image, and it has a border around it that we do not want. To hide it, we go to the image background color or the state background color to match the display background. Or you can select the image scaled box to fit to our desired box. Now state 0 is done, and we need to add our state 1 for auto. This can be done by replicating the same steps, but selecting the image with the switch pointed to the right. That will finish creating the states for our selector switch, but we need to go to the connections to add a tag to toggle between our states. We could create local HMI tags and use the tag in the connections, or you can set up a direct reference to a PLC tag. HMI tags allow you to create more legible names so that your objects have easy to interpret connections. Then the connection to the PLC is handled by the HMI tag creation. To add a direct reference tag, we first need to set up the communications to the PLC within our project. When developing, there are two different ways that you can populate the tag browser. Inside the communications setup, you can map the address of the PLC, or you can add an offline file. Both methods require you to set up a shortcut for the PLC. If you want to develop offline, then you can select the Browse button on the middle right side of the communications setup page. This will allow you to browse for the PLC ACD project file. Also, if you're developing offline, you can manually create the shortcut path in the design window. The easier method is to get the PC on the same network as the PLC and create a path by browsing. When you add the shortcut and browse in the design window, you need to make sure that you highlight the controller and select the Apply button above the shortcut name. With the controller highlighted and the offline tag file path added, you'll need to select Apply, and that will save and store the path for the tags. At this point, it is also best to select the Copy Design to Runtime button. You can manually create your runtime shortcut, but it is much easier to copy. Once you have both the design and the runtime paths created, I would recommend pressing the Verify button. This will launch a pop-up to let you know if the shortcut has been assigned to a controller. If there is something wrong with the shortcut, the Verify feature is where you will find the issue. Now that our communications path is set up, you hit the ellipses and launch the tag browser. After the tag browser pop-up loads, you need to browse the PLC and find the proper tag. If an offline tag file was added, then the tag browser will have an online and offline folder. We will use the online folder, and for the selector switch, we are going to use the tag called mode_switch. When you use the tag browser and select the proper tag, it will fill in the proper syntax for you. The syntax gets even more complicated if it is a program scoped tag, because the tag name is no longer just the tag name. Program tags have references to the program folder as well as the tag name. When working with program tags, you must make sure that you are not using local, otherwise the HMI will not be able to access the tag. We will add the same tag to both the value and indicator connections. Value is the tag that will be modified by the button, and the indicator is the tag that will show the current state. Now we need to test the object, so we will select Save and then press the Play button to test the display. When we press the object, we see that it changes state, and that can also be verified by connecting to the controller and monitoring the tag. To stop testing, press the Stop push button, and then we will add text to identify the current state's names. We will add a text box and use the word manual with bold white font. Then copy and paste to create a second text box, but we'll change the word to auto. Then we're going to align them so that the selector switch points to the proper text. Moving to the next item in our list, we will build a simple indicator using a rounded rectangle. The object will be used to notify us that we have entered webinar mode. Since we only want to be notified when we are in webinar mode, we can animate this object with color and visibility. To add animations, you right-click on the object, select animation, and then pick from the list provided. When creating animations, the action occurs when the expression or tag equates to true. That means we want to set the object as visible when the webinar_mode tag is 1 or true. We will also use the color tab to change the object to red when the tag is true and green when it is false. When you select apply, it will add all the changes to the object. If you wanted to edit the animation, you can return to the animations window and look for the check mark next to the tab name. We will delete the visibility animation but leave the color animation. With the animation done, we need to match our size of our selector switch. So in the properties, we assign the height and width of 100. Then we can select the objects and align them so they are stacked. We're going to test this by hitting save and then play. If we are in the webinar mode, the controller is ignoring physical I/O and our indicator will turn red. Indicators are great for showing various statuses and can be quickly created or modified with animations. The next item is another common visual aid, which is a tank level indicator. We're going to launch the symbol factory and we're going to add a tank to our graphic. To change the size, it is best to use the property panel. That way you size the whole object and not just one piece of it. We want our group height to be 200 and width to be 100. Then we need to add a cutaway to our tank, which is also located in the symbol factory. We want to add a cutaway so that we can animate it and position it directly over our current tank. We will align the center of it and adjust it as needed to make it look good. With the cutaway in position, we want to add a fill animation. The animation range is going to use a constant between 0 and 100. Then we will select a tag and browse for our tank level tag and then click apply. We can now test it, but the animation is applied to the whole cutaway, which doesn't look right. We want to see the outline so it doesn't just disappear, and that is a part of the settings. So go back to the fill animation and there's a checkbox for inside only, which is exactly what we need. Once we check the box, we then hit apply, save, and test to make sure that everything looks as expected. There are many other ways to accomplish level indication, but this is one common visual method. The next item we want to add on our screen is a numeric input to change the time delay after sensor 1 is no longer active. First, we need to hit stop, and then we're going to add a text box to label the input. The label will be delay after sensor 1. And we will change the font to bold and white and then select OK. We'll use the numeric input, which is shown in the header, and select and drag the object to the size we want. We will leave the appearance as default for now and then go to the label to add our time so that we can see the current value for the time delay. To add the current time, we select Insert Variable for the caption. Select Numeric, select a tag, and then use the ellipses to browse and find the preset tag. Since this is on a timer on instruction, we need to search for the folder with the timer's name. Then we will adjust the number of digits to 6 since the timer uses milliseconds for time. Once the label is created, we need to go to the numeric to configure how we will enter the value along with the min and max values allowed. The pop-up allows you to choose from keypad, which launches a numeric window, a scratch pad, which allows you to write in a value, and none, which can be used if you have an external keyboard and don't want to have a pop-up at all. Let's also set the limits from 0 to 60,000, which is 60 seconds. We could tag it to a variable instead of hard-coding a value into the project. We will skip the timing tab, but that tab has the duration of how long to hold enter or handshake timing if needed. We will go to the common tab to size our object, where we will use 50 for height and 150 for width. The last tab will be the connections, where we assign the value tag, which is the tag in the PLC that we will overwrite. We will select the same tag that we used for our caption variable so that we will write to the tag and see the value change. You can also see some additional tags such as min and max, which came from the numeric tab, as well as enter and handshake, which come from the timing tab. We will leave the rest blank and select OK to finish that configuration. We need to save the changes, and then we can test the display, which will show us our 10 seconds. It comes across as 10,000 because the timers always use milliseconds. If you wanted to change that so that you had proper units on the screen, you can use an HMI tag that is scaled, or you can create a separate tag that is written to the preset time inside the PLC. Using a PLC tag is the most common method and allows you to change the scaling of the timer prior to writing it to the timer on instruction. If we wanted to change the timer to 5 seconds, then we can enter 5,000 milliseconds on the keypad pop-up. Also, you can see that the pop-up shows the limits as well as the current number along with the new number entered. The next item to build is a multi-state indicator. Select the multi-state indicator object from the header and size it close to our numeric input object. Then it will launch the configuration window, where we will skip the appearance and go to the States tab. The maximum number of states that you can configure is 2,000. This was added to allow people to create their own alarm or information objects instead of using the pre-built screens. We will build a 3-state object for our tank state with a trigger type of value. Value is the most common setup for newer controllers, but LSB, or least significant bit, is the most popular with older programs. Going to the States tab, we will have State 0 as static, State 1 is draining, and State 2 is filling. We will go to the Connections tab to assign a tag to monitor for our state. Since we have more than 2 states, we cannot use a Boolean tag. We will select the tag for our indicator and choose our tank_state tag. Click OK and save and test the display to see if the object changes as expected. Based on our sequence, it does seem to work. Next, we want to create some simple navigation between screens, but we should align our objects and group them to make alignment easier. This is not a necessary step, but it's always a good practice when creating screens. To add navigation, we need to create another screen, which we will do by simply duplicating the current screen and renaming it to PDF. Once the new screen is created, we need to go to the startup and define which screen is run on initial startup. We will choose our main screen. You can select multiple screens, especially if you want to create banners for all the screens. Also, on startup, you can tell it if you want to run alarms, info, and audit trails by checking the boxes on the top. Now that we have 2 screens and assigned main as our startup screen, we can add the GoToDisplay object. Select the object and size it similar to our shutdown button. On the Properties window, we need to select the display that you will navigate to, but it also allows you to pass parameters if you need for faceplate configurations. Then we will add a label called GoToPDF Screen, but we do not need any connections for this object. Now we need to add navigation back to the main screen. The best way to do this is to copy using Ctrl-C and paste using Ctrl-V the object onto the second page. It will automatically copy the configuration as well as the position of that object for you. Then we just need to edit the display to move to main and the label to main. Once that is done, you will have to select Save for both screens, so this requires you to hit Save twice. We can test our main screen, but if you select the navigation button, it won't do anything, and you will see a warning in the log window in the bottom of the screen. That is because the test display doesn't work for navigation. You can hit the Run Application window to test, but we will skip that until we add our final item. The last item we will add is on the PDF screen, which is an ActiveX control to launch a PDF manual. The ActiveX object looks like an X on the header bar and we can add it just below our navigation button. It will launch a full list of all the ActiveX controls, which is quite an extensive list. Use caution when using ActiveX controls because some of them will stop working when you upgrade the firmware. We will scroll down till we find ME Program Launcher and then click OK to launch the properties. There are no appearance configurations allowed, but you can still size the object using the Common tab, and the most important tab is the Connections. For today's demo, we will set up the object to run on the local PC, which will be different when you implement for a PanelView. The knowledge base has a nice tech note running through the specifics for a PanelView PDF launcher object. I will use the expression editor to paste the application shortcut I will be using in this demo, which is the Chrome editor. Be sure to have quotes on both ends of the shortcut, and then you can verify by selecting the Check Syntax button. The program parameter is the name of the file that you want to launch, which is also added in the expression editor. Launch Enable allows you to trigger the PDF from the PLC, but for our demo, we can just select the object. Now we are done configuring the button so we can apply, select OK, save, and test the application. For this object, the test display works, but not all ActiveX objects work with test display. We will press the test application button, which will compile the project and launch a screen in the top left corner of the PC. This will start with the main screen, and then we can press the navigation button to navigate to the PDF screen. That works, and now we can select the ActiveX object and it does launch the PDF. Again, don't forget the shortcuts will be different when you are using a PanelView. You can close the test application by hitting the X button on your keyboard at any time. But that will complete all of the objects that we planned on developing, animating, and testing. Thanks for watching. If you have any questions, please contact your local ES&E account manager or automation specialist.